Bismillahirrahmanirrahim. My name is Sintakhab Alam, and this was the paper you can watch here of October, November 20, paper 42. It's A levels structured paper. The next question is from oscillations. And in the oscillations, we should be very much clear that normally it is with the simple harmonic motion. The question is, there is a simple pendulum which consists of a metal sphere suspended from a fixed point by means of a thread as illustrated over here. So there is a sphere, mass is given, taken to certain height, and its displacement from the mean position is 12.7, and you know it will go to the other side as well. This information is there. The sphere is released so that it oscillates. The sphere may be assumed to oscillate with a simple harmonic motion. State what is meant by the simple harmonic motion, please. Again, the format of the question is exactly the same. The first part of the question is simple knowledge-based question. Simple information you have to provide. So simple harmonic motion is, please remember only one equation, and then we can explain it. Then we can state it that acceleration is directly proportional to minus x. X is the extension from the mean position. Acceleration produced is directly proportional to the extension from the mean position and is also directed towards the mean position. Such a motion is called simple harmonic motion. If in any oscillation, the acceleration produced is directly proportional to extension from mean position and is directed towards mean position as well. Is called simple harmonic motion. Very clearly, examiner is behind the information, and that information is that you have to state this acceleration is directly proportional to the extension from mean position and is directed towards the mean position. If he will get this information, he'll definitely give you both of the marks. Moving on to the next part, he says state the kinetic energy of the sphere when the sphere returns to the displaced position as shown in the figure. So the displaced position. So where is the displaced position? If you can get the displaced position, this is the maximum distance from the mean position. So whenever it is at the maximum position from the mean position, so the kinetic energy without any calculation is 0 joules. Why? Because the object is at rest. When the velocity is 0, how come the kinetic energy? It is also 0. Then he says, calculate the total energy of the oscillations. So we have to go for the total energy of the oscillation. So we can go for the total energy of the oscillations, which is called the ET, or any symbol can be used for the total energy. So definitely ET is its maximum potential energy. That would be its ET, or the maximum kinetic energy, because we have its total energy is the maximum potential energy GPE or maximum KE. As we can easily get the maximum GPE because we are given with the height, we are given with the mass. So we do not have the information about the velocity. So better to go that the total energy is equals to the total or the maximum. Better to use the word maximum over here because I have already stated it as maximum. So I should write it word maximum EP, which is equals to mg and del H or mgh. The mass is given to you. If you can get the mass 94.0 grams. So 94.0, and you should multiply it with 10 raised to minus 3 so that it is converted into kilograms, because we have to use all the values in the SI units. And the height is 0.9 centimeters. Gravity is no doubt 9.8. Height is given as 0.9 centimeters. So we'll also convert that. 0.9 would be multiplied by 10 raised per minus 2. So it would be converted into meters. So getting this all and multiplying, we can easily get the value for the total energy in this case, which is simply 8.3 into 10 raised per minus 3 joules. 8.3 into 10 raised per minus 3 joules is the total energy. Moving on, he says, use your answers into, please read the question carefully, because that every next part gives the hint how to solve the question. Be careful, read the question carefully, use your answer into to show that the angular frequency omega of the oscillation of the pendulum is this. So he's asking about omega. And if we are going to use the answer into, so the answer into is we have got its maximum energy. We have got its total energy. So we have the total energy, and the value of the total energy is 8.3 into 10 raised per minus 3 joules. So now we have to find the link between the total energy and its omega. And if we can remember that relation, that the E maximum is always half of M into V naught square, that is very clearly we can have an idea that the E maximum or total energy is also equals to, as I have said, it is also equal to maximum EBVP, or the total energy is also equals to maximum EK. For the maximum EK, this is half of M into V maximum square. V maximum square. So for V maximum, as we know that this is called V naught as well, and V is equals to R omega generally. And in this specific case, this R is equals to the maximum displacement. So we call it X into omega. So relating this V max or V naught with X into omega, so we get the relation is equal to half M into X square and omega square. As you have the value of the total energy, so it's very simple for us to get the value of the omega out of it. So putting the value of the total energy as 8.3 into 10 raised to minus 3 and getting it half, and the mass we knew and X we knew, the X is from the mean position is 12.7 centimeter. And the mass is 94 grams. So from the for the 94, this is 94.0 into 10 raised to minus 3. And for X square, we have 12.7 into 10 raised to minus 2. Don't forget to put the values into standard meters multiplied by omega square. So making the subject and getting the value of the omega. So we can easily get the value of the omega out of it. And omega would be very clearly from here exactly equal to 3.3 radians per second. Finally, omega is 3.3 radians per second, because the answer was already given to us. So we have to directly prove it, and we have proved it. Then the most interesting and the last part of the question says that period T of the oscillation of the pendulum is given by this expression, where G is the acceleration of the free fall and L is the length of the pendulum. Use the data from B. So again, we are linked with the previous relation, and we have to find the value of the L. T is the period of the oscillation. And this is what is the information in front of us. 2 pi under root L over G is the information. So definitely now we have to go into the detail, and we have to get the value of the L. And we can get now from the omega, because we have got the omega, that omega will lead us to get the value of the T. Because the hint is there. He's giving us the hint that use the answers in the B. So we have the B, the total energy, and we have got the omega. So first of all, we have to understand what is the relation of the time period with omega. As you know, omega is equals to 2 pi divided by the time period. So from here, the time period would be simply, we can get the time period is 2 pi over omega. So getting the time period first of all, then we can get the other values as well, putting the value in place of the time period, 2 pi over omega. So in the relation we already have, we start with the relation t is equals to 2 pi under root L over G. Putting the values in front of the t is 2 pi over omega, and that is also equals to 2 pi and under root L over G. We must take the square both sides. So this is 1 over omega is equals to L over G under root. Squaring both sides, it gives 1 over omega square is equals to L over G, and just cross multiplying and making L the subject of the equation. So this is G divided by omega square. So G is 9.8. We knew omega is 3.3 square. So we would be able to get the value of the L out of it. So the L over here is very clearly 0.9 meters. After calculations, we can get the value of the L as 0.9 meters. Hope you have got it.